Yeah, hello friends, I need a test chart in color for well, the purpose of testing the monitor, and I produced one in Euler's Toolbox, and I think it's a good idea to show you how to do that. Well, for the start we define a matrix M, and let's make it 200 pixel high, 200 pixel high, and maybe 1000 pixel wide. So that's just a simple matrix of ones, or 200 and 1000 elements, 200 height and 1000 width. We can make an RGB color matrix out of that by using the function RGB. Let's take M, and that's the red value. So we have fully red. 1 means fully red. And for the red, green, and blue values, we take 0. Remember, the matrix language tells us that the arguments are now spread out to the largest argument, which is this matrix. So we have actually now a matrix with red values 1 everywhere, 200 times 1000, and green and blue values 0. So this is our RGB matrix. The entries of this matrix are not very interesting. Let's just look at one. Well, this is something which is decoded in some way, and not interesting, and we can hardly interpret that. So what we do is now we save that on a file. So the matrix, and see the color matrix, save that to a file. Let's call that test.png. And if you do that, it will be saved in the current home directory of Euler. I don't want to do that, and that's why I save the whole notebook on my desktop. There it is. Well, so once we now start saving, we get a PNG file, which is a red, simple red, well, area, rectangle area, 200 pixel high and 1000 pixel wide. If I double click that, the Windows photo display will show me the content of the file. Well, that's not what I want. I want a file which goes from dark red to bright red. So what I do additionally is I take a scale which is lens-based from 0 to 1, and I need exactly 999 spacing, so that's 1000 points. And now I multiply the matrix M by the spacing. So we have to be careful now. So the matrix looks like that. So it's rectangle, and the S is a row vector. And that means that each row of M is multiplied by S. Yep. That's how it looks. Well, we can also insert this image now into the notebook. RGB files can also be printed on the plot window, but it's not necessary to do that here. Ins image needs, I think it's the other way around. It's load image. That's the reason. Yep, file name and then the number of lines, like that. So now we want to make a blue, red, green, and blue bar of the same kind and put it below that. That's easily done. We take below that matrix, we concatenate another matrix which is 0, m times s, 0, and below that another one which is 0, 0, and m times s. Looks like that. That's nice. We want also a gray matrix on top of it, and maybe also below. So we make a new line here by pressing Ctrl Shift Return and make a gray matrix which is floating from left to right. So it is RGB, m times s, m times s, m times s. All colors are our gradiated matrix M, and we put that on top of it or below it. Yeah, you should notice that the matrix, the RGB values go from top to bottom. And on the bottom, on the top, I will take the flipped. That is flip. What is it? Flip up, down, yeah. Flip up, no, left, right. You can look down here, flip left, right. That's the correct thing to do. G, and another one. So now I have a gray bar which goes the other way around. And I might have white border around that. So how do we do that? Well, for that we will take a matrix which is a little bit larger. So now we have 1000 cross 1000 matrix, and we want maybe a 100 pixel border around it. So we take a matrix M L equals 1200, 1200, and the picture itself, let's call it P, is RGB M, all white. And now we set the center of P to the matrix that we already have. So we set P. How is that done exactly? It is approximately from 100 to it should be 1099. Let's see if that works. 100 to 1099. It's exactly 1000 pixels. We set this equal to C. Aha. This should be LLL. So that was my fault. Yep. So the matrix P, the white matrix, is of course as large as L, and we are now printing P, of course. So this gives us this matrix, which I should show you inside the box. So this is our color chart. Well, easy to do. And it all depends on the RGB function, which is that function. And it takes red, green, blue matrices and puts them together to a file which can be saved as a PNG. And that's all. Well, have fun.